Students, I Dr. Jyoti Gupta. Today I will discuss the topic matrix, and here we discuss some problem of consistency, inconsistency, and eigenvalue and eigenvectors. So we know that consistency is if the augmented matrix rank and coefficient matrix both are is equal, then equation is consistent. And if rank of A is not equal to rank of augmented matrix, so equation are inconsistent. So now we discuss one problem, that is solve x plus 2y plus 3x is equal to 14 and 3x plus y plus 2z is equal to 11 and 2x plus 3y plus z is equal to 11. We know that the matrix equation, that is Ax is equal to V. Here A is coefficient matrix, X is unknown matrix, and V is constant matrix. So augmented matrix is A colon B. So we given augmented matrix, that is A colon B is equal to 1 2 3 colon 14. So this is first row, and 3 1 2 colon 11, this is equation 2, that is R2, and third row, that is R3, 2 3 1 colon 11. Now we apply operations or E transformation. So we subtract row second minus row first, that is R2 1, and in first row we multiply minus 3, so we get 1 2 3 and 14. Because we use R2 minus 3, so we get in second row 0 minus 5 minus 7 minus 31, and the second operation, that is R31 minus 2, so we multiply 2 in first row, and we subtract row 3 in row 1, we get 0 minus 1 minus 5 minus 17. Again we apply R2 interchange R. Three, so that 1 2 3 14, 0 minus 1 minus 5 minus 17, 0 minus 5 minus 7 minus 31. Again we operate row 3, multiply minus 1, so R2 minus 1 is equal to 0 minus 5 minus 7 minus 31. Again apply R3 10 to R3 plus 5 R2, that is 1 2 3 14, 0 1 5 17, 0 0 18 54. Again we operate R3 1 by 18, so we get 1 2 3 14, 0 1 5 17, 0 0 1 3, which is echelon form, because here 3 rows are non-zero rows. So rank of A colon B is equal to rank of A. Here this is matrix A, or here we get 3 non-zero rows, so rank of A is 3, and also augmented matrix, that is A colon B, that is first row, second row and third row, so 3 non-zero row, so that rank of augmented matrix, that is A colon B, is equal to also 3. Here rank of AB is equal to rank of A is equal to number of unknowns is equal to 3. Hence the given equation are consistent and have a unique solution. Here equation 1 can be written as follows: x plus 2x plus 3z is equal to 14, y plus 5z is equal to 17, z is equal to 3. After solving, we get x is equal to 1, y is equal to 2, and z is equal to 3. Now we take next problem, that is for what values of lambda and mu do the following equations, that is x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10, and 2x plus 2y plus lambda z is equal to mu. Here augmented matrix is equal to A colon B, that is 1 1 1 1 2 3 2 2 lambda, and here D is equal to 6 and D2 10, D3 mu. Apply transformation R21 minus 1 R31 minus 2, so we get 1 1 1 6 0 1 2 4 0 0 lambda minus 2 mu minus 12. Here third row subtract by row first, so we get 0 0 lambda minus 2 and mu minus 12. Here three cases arises. First case is if lambda minus 2 does not equal to 0, that is lambda does not equal to 2, then rank of is equal to rank of AB is equal to 3. Hence in this case the equation are consistent and will have a unique solution. Second case, if lambda minus 2 is equal to 0, that is lambda is equal to 2, and mu minus 12 is equal to 0, that is mu is equal to 12, then rank of A is equal to mu rank of AB is equal to 2. So 2 is less than number of unknown. So here this case the equation are consistent and will have infinite number of solutions. Case third, if lambda minus 2 is equal to 0, that is lambda is equal to 2, and mu minus 12 does not equal to 0, that is mu does not equal to 12, then rank of A is equal to 2 does not equal to rank of AB is equal to number of unknown 3. Hence in this case the equation are inconsistent and have no solution. Now student, we will discuss a new topic, that is eigenvalue and eigenvector. So here characteristic matrix for a given square matrix A, the characteristic matrix of A is called A minus lambda I, where lambda is a scalar and I is a unit matrix. Let A is equal to 2 2 1 1 3 1 1 2 2, then A minus lambda I is equal to 2 minus lambda 2 1 1 3 minus lambda 1 1 2 2 minus lambda. This is characteristic matrix. Characteristic polynomial, the determinant A minus lambda I when expanded will give a polynomial which we call as characteristic polynomial of matrix A, that is 2 minus lambda 2 minus 2 1 1 3 minus lambda 1 1 2 2 minus lambda. Now we solve determinant, so we get 2 minus lambda 3 minus lambda into 2 minus lambda minus 2. minus 2 into 2 minus lambda minus 1 plus 1 into 2 minus 3 plus lambda is equal to 2 minus lambda square minus 5 lambda plus 4 minus 2 into 1 minus lambda plus lambda minus 1 is equal to minus lambda cube plus 7 lambda square minus 11 lambda plus 5. Now, characteristic equation. The equation determinant A minus lambda is equal to 0 is called the characteristic equation of the matrix A. So lambda q minus 7 lambda square plus 11 lambda minus 5 is equal to 0. The roots of the characteristic equation determinant A minus lambda is equal to 0 are called characteristic roots or eigenvalue or latent roots or proper value or a spectral value of matrix A. So we get lambda q minus 7 lambda square plus 11 lambda minus 5 is equal to 0. Then we get lambda is equal to 1, 1 and 5. Find the characteristic roots of the matrix. Next problem. So A is equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. The characteristic matrix is A minus lambda is equal to 6 minus lambda minus 2, 2, minus 2, 3 minus lambda minus 1, 2 minus 1, 3 minus lambda. Characteristic equation, that is determinant A minus lambda is equal to 0. 6 minus lambda into 3 minus lambda whole square minus 1 minus 2 minus 2 3 minus lambda minus 2 plus 2 into 2 minus 2 3 minus lambda is equal to 0. 6 minus lambda into lambda square minus 6 lambda plus 8 plus 2 into 2 lambda minus 4 plus 2 lambda minus 4 is equal to 0. Now after simplifying we get 6 minus lambda into lambda square minus 6 lambda plus 8 lambda minus 16 is equal to 0. 6 lambda square minus 36 lambda plus 48 minus lambda cube plus 6 lambda square minus 8 lambda plus 8 lambda minus 16 is equal to 0. Minus lambda cube plus 12 lambda square minus 36 lambda plus 32 is equal to 0. Now we multiply minus both sides, so we get lambda q minus 12 lambda square plus 36 lambda minus 32 is equal to 0. Now we take lambda is equal to 2 be a root of this equation. So we put lambda minus 2 into lambda square minus 10 lambda plus 16 is equal to 0, and lambda minus 2 lambda minus 2 lambda minus 8 is equal to 0. Now so we get eigenvalues are lambda is equal to 2 to 8. Eigenvector corresponding to lambda is equal to 2 is given by A minus lambda I, x is equal to 0. We get 4 minus 2, 2, minus 2, 1, minus 1, 2, minus 1, 1, and unknown matrix, that is x1, x2, x3 is equal to 0 matrix 0, 0, 0. Now apply operation. R2 tend to R2 plus 1 by 2 R1 and R3 tend to R3 minus 1 by 2 R1. So we get 4 minus 2, 2, 0, 0, 0 and 0, 0, 0. We get only independent equations, that is 2x1 minus x2 plus x3 is equal to 0. Let x1 is equal to k1, x2 is equal to k2, x3 is equal to minus 2k1 plus k2. Here k1, k2, k3 are arbitrary constant. So eigenvector x is equal to k1, k2 minus 2k1 plus k2 is equal to k1 1 0 minus 2 plus k2 0 1 1. Similarly, eigenvector corresponding to lambda is equal to 8 is given by a minus lambda I into x is equal to 0. Now minus 2 minus 2, 2, minus 2 minus 5 minus 1, 2 minus 1 minus 5, x1, x2, x3 is equal to 0, 0, 0. So here this is 0 matrix. After solving, 2x1 minus 2x2 plus 2x3 is equal to 0. Dividing by 2 both sides, so we get x1 minus x2 plus x3. Again 2x1 plus 2x2 minus 2x3 is equal to 0, and again 2x1 minus 5x2 minus x3 is equal to 0. 2x1 minus x2 minus 5x3 is equal to 0. So x1 upon 12 is equal to x2 upon minus 6 is equal to x3 upon 6 is equal to k, that is x1 by 2 is equal to x2 by minus 1 is equal to x3 by 1. Here divided by multiplying 6 in numerator, we get this is equal to k. K is a arbitrary constant, so that eigenvector corresponding to lambda is equal to 8 is x3 is equal to k into 2 minus 1 minus and plus 1. Now student, we discuss other topic, Cayley-Hamilton theorem. So Cayley-Hamilton theorem statements is every square matrix is satisfy its own characteristic equation. So we discuss a problem. Verify Cayley-Hamilton theorem for the matrix A is equal to 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Hence compute A inverse. Solution. Here characteristic equation, determinant A minus lambda is equal to 0. Determinant 2 minus lambda minus 1 1 minus 1 2 minus lambda minus 1 1 minus 1 2 minus lambda is equal to 0. Now solving determinant, we get 2 minus lambda into 2 minus lambda whole square minus 1 plus 1 into minus 1 2 minus lambda plus 1 plus 1 1 minus 2 minus lambda is equal to 0. That is 2 minus lambda, lambda square minus 4 lambda plus 3 plus lambda minus 1 plus lambda minus 1 is equal to 0. 2 minus lambda into lambda minus 1, lambda minus 3 plus 2, lambda minus 1 is equal to 0. And lambda minus 1, 2 minus lambda into lambda minus 3 plus 2 is equal to 0. Lambda minus 1 minus lambda square plus 5 lambda minus 6 plus 2 is equal to 0. Lambda minus 1 minus lambda square plus 5 lambda minus 4 is equal to 0. We get lambda q minus 6 lambda square plus 9 lambda minus 4 is equal to 0. Now we get lambda q minus 6 lambda square plus 9 lambda minus 4 is equal to 0. Here lambda q minus 6 lambda square plus 9a minus 4i is equal to 0. Now we find a square. So a square is equal to 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6, and aq is equal to a into a square. So this is a and this is a square. So multiplying both matrix, so we get uh, 22 minus 21, 21 minus 21, 22 minus 21, 21 minus 21, 22. Now substituting the value of aq, a square, a and I into the characteristic equations, that is aq minus 6a square plus 9a minus 4i is equal to 0. So we put the value of aq, this is a square and this is a, and this is unit matrix I is equal to 0 0 0. After solving above equation, we get 22 minus 36 plus 18 minus 4 is equal to 0, or minus 21 plus 30 minus 9 minus 0 is equal to 0. So verify Cayley-Hamilton theorem because left hand side is equal to right hand side. Now we find A inverse. So a square minus 6a plus 9i minus 4a inverse is equal to 0, or 4a inverse is equal to a square minus 6a plus 9i. 4a inverse is equal to, this is a square minus 6, this is a plus 9, and this is I. So simplifying this matrix, R 6 minus 6 12 plus 9 minus 5 plus 6 plus 0, 5 minus 6 plus 0, minus 5 plus 6 plus 0, 6 minus 12 plus 9 minus 5 plus 6 plus 0, 5 minus 6 plus 0 minus 5 plus 6 plus 0, 6 minus 12 plus 9. After solving we get 3 1 minus 1 1 3 1 minus 1 1 3. So A inverse is equal to, now cross multiply 4 here, so we get 1 by 4, 3 1 minus 1 1 3 1 minus 1 1 3. Thank you.